I'm going to find the ratios of these angles. SOHCAHTOA, remember, is the memory device, so we know we can memorize the ratios. There's only 3 ratios. There's a sine, the cosine, and the tangent, which I'm asking you to find. Okay. Sine, cosine, and tangent of each acute angle. So I set it up. Sine, cosine, tangent of x, sine, cosine, tangent of y. Let's do this. I trust everyone has a calculator out, like mine. Okay. You have your calculators out, so you guys are going to tell me the ratios. You're going to calculate them for me by punching them in. So the sine of x, here we go. Let me get in green here. The sine of x, check it out, is opposite over hypotenuse. My God, what side is opposite x? What side is opposite x? Beautiful. Okay. Hypotenuse. Almost. What side is the hypotenuse? 20. Would someone please, out of the kindness of their heart, hit 16 divided by 20 on their calculator? Tell me what you get. What's 16 divided by 20? Degrees. Yep, make it on degrees. My bad. Remember, make sure your calculator has DEG showing, not radians. Make sure degrees is showing. 16 divided by 20. Would anybody help me out? Are you guys going to make me do all the work? 16 divided by 20 your calculator. Help, anybody. 0 point what? Thank you. Let's go on to cosine now. Look at cosine. Adjacent over hypotenuse. Adjacent to x. Adjacent to x now. Remember, adjacent means touching. Nice. So here's x. This side's touching, so it's 12 over, the ratio of 12 over hypotenuse is 20. 12 divided by 20, my God, help me. 12 divided by 20, someone with a calc. Awesome. Be sure. I think you're on radians. Check it, radians or degrees. Something happened then. Let's go tangent now. Tangent is opposite over adjacent. Opposite of x. 16. Adjacent, 12. Let's run to the nearest 4th decimal. 16 divided by 12, anybody? What's 16 divided by 12? 1.3. Nice. .33. Let's go to the 4th decimal, because the direction said 4th decimal, notice. So 1.333. 3. 4 threes. Cool. All right, moving right along. Moving right along. All right. Sine of y. All right, y now is the other acute angle. Look at sine, SOHCAHTOA. The sine is opposite over hypotenuse. So opposite of y is 12, hypotenuse is 20. 12 divided by 20. Hey, that looks pretty familiar. We already did 12 over 20. Look, it's right here. It was the cosine of the other acute angle. That's the time saver, 0.6. That's cool. Cosine of y. Cosine is adjacent over hypotenuse. This is h, by the way. Adjacent over hypotenuse. Adjacent to y is 16. Hypotenuse is 20. That looks familiar also. Look at, y'all is the sine of the other acute angle. That's a time saver, so that's 0.8. Question so far. I'm going kind of fast, but I trust you guys are with me. Horton for sure is with me. Right, Horton? Told you. Raina. Come on, man, you're killing me. Tangent of y. Opposite over adjacent. Opposite of y, 12. Jason, 16. 12 divided by 16. Someone with their calculator, please. 12 divided by 16. Nice. We got all 6 ratios. Talk to me. Sine, opposite over hypotenuse. Well, the sine of an angle is the opposite over hypotenuse. Opposite over hypotenuse. Oh, okay, got you. Yeah, you just go like this. Sine equals opposite over hypotenuse, like that. Cosine equals adjacent over hypotenuse. So, and then tangent is equal opposite over adjacent. Is that? There it is. So, toa. All right, now, watch this. Stay with me. Warm up. I'm going to copy that down. Yeah. It's up to you. My preference is example 1 of today's notes, but it's up to you. Yeah, this is notes now. Going to copy that down. Let's find the sine, cosine, and tangent of both acute angles. I'm going to go quickly here because I went slowly on the warm-up. Let's do it one more time. So we have R, we have S. We're going to find the sine, cosine, and tangent of both. So sine of R, cosine R, tangent R. Far so good. Dodgers won, so I'm using blue now. Sine of S, cosine S, tangent of S. Notice how I'm always doing it with the acute angles only. Okay, the acute angles only. You never do trigonometry from the perspective of the 90-degree angle. It's only the 2 acute angles. Let's do it. Let me write my SOHCAHTOA up here. SOHCAHTOA. Let's do it. All right, I'm gonna the sine of R is opposite over hypotenuse. Opposite over hypotenuse. So opposite of R is 12. Hypotenuse is 13. So 12 over 13. Someone with a calculator, 12 divided by 13, the nearest decimal. Nearest 4th decimal, if you would. 12 divided by 13. You guys got the calculator open. Help me out. 12 divided by 13. 19? Keep going to the 4th decimal. 19 what? 4th decimal. 0.9 or 19? Okay, 0.9. Let's go to the 4th decimal. 9, 1, 2. So there's 0 next to 3, so it stays at 3. Okay, so that's the 4th decimal. Moving right along. Here we go. Cosine of R. Here we go. Cosine. I did? Okay. 0.9. No, there's no 1. Huh? Got you. My bad. What's next to the 0? To the right of the 0. So that means it turns into a 1 then. So it's 0.9231. Because next to the 0 is 5 or bigger, it made the 0 a 1. If we were going to round to the 4th decimal, if you look to the 5th decimal and see if it's 5 or bigger. Cosine of R. Cosine is adjacent over hypotenuse. 5 over 13. Calculator, people. We do it. 5 divided by 13. Help. 0 point what? Divided by 13? 0.3816. Cool. Let's do tangent now. Tangent is opposite over adjacent. Tangent of r is opposite 12 over 5. That's going to be 2 point something. 12 divided by 5, anybody? It stops at 4? Cool. All right, let's do the sine of x now. Sine of s. We're at the other acute angle now. Here we go. Sine of s. Okay. Sine is opposite over hypotenuse up here. Opposite of s is 5. Over hypotenuse is 13. Hey, that looks familiar. That looks like this one, cosine of r. Right? So it's going to be this again, 0.3846. Cosine of s. Cosine of s is adjacent, notice, adjacent over hypotenuse. So adjacent over hypotenuse is 12 over 13. That looks familiar. That was this one. That's 0.9231. And last but not least is s. Tangent of s is opposite over adjacent. That's going to be 12 or 5 or 12. Notice how it's the reciprocal of the previous tangent. You flip it. Instead of 12 over 5 becomes 5 12s. Anybody with a calc? 0 point what? Got you. So far, so good. Now, talk to me. Should be a 7, huh? Careful there, little guy, right? This should be a 7. Right, but if I say to round to the 4th decimal, you look at the 4th decimal and look at the 5th decimal. This is the number you look at if it's 5 or bigger to make this one go. If I was going to round to the 100th place, then this would be 0.42 and I'm done. If I'm rounding the 4th decimal, what number was this, Valguera? Right, so 666, so that becomes a 7. Right, Padilla? Stay with me, Padilla. Valguera, watch this guy. He's going away. Catch him. He's leaving me now. I'm starting to see signs of the old Padilla. Don't let him go to the old Padilla. All right, here we go. So, watch this. Now I'm about to tell you how we're going to find the height of this building. Remember I was kneeling down with my chronometer last week? The angle of elevation was 63 degrees. With my laser beam, I was able to tell that when I was kneeling down, I was 6.75 feet away from the wall. Now, how am I going to find this? Here's how. Watch. You have your calculator in front of you. I'm about to give you the power now, the power of trig. Watch this. Watch this. What was the sine of r? The sine. What was the ratio again? What was it? What was the ratio of the sine of r? No, everything that we wrote here. What's the sine of r's ratio? What is it, Ronald? What's the sine of r, this ratio? Isn't it right? Wasn't it this? Right, the sine of r, it became this. Okay, 0.9231. That ratio came, where did that ratio come from? Well, we took the opposite over the hypotenuse, it became that, yeah? Now, on your calculator, make sure it's on degree mode. I measured this angle. Look at, I measured this angle right here. It was actually 67.4 degrees. Okay. What, this one? That was angle S. I'm not giving you the degrees of that one yet.
No, I'm saying that.
Oh, this is the side opposite, huh? It was opposite to angle R because it wasn't touching angle R, right? Opposite over hypotenuse, the ratio was that. Now, on your calculator, go ahead and type in the button, hit sine. Instead of R, I'm going to type in the degrees of R. Hit 67.4. Tell me what you get on your calculator. Type sine, hit the sine button, and hit 67.4, then hit equal. What do you guys get? You guys get 0.9232? Like Melgar? Vamos, you get it? Padilla, you get it? Alright, I'll wait for you guys. Hit sine 67.4 degrees. You got it? I'll wait for Padilla. And Padilla. So hit sine 67.4 degrees. It's the little sin button. Watch, looks like this one. You got it or no?
Yeah.
Padilla, you get it? Okay, right. It's this one, huh? Remember we got this? The way we got this number is we took 12 Salazar divided by 13, right? The calculator, what the calculator has done in its mind, you can say the calculator has a mind, is it knows that an angle of 67.4 degrees, the ratio of the side that's opposite, here's the key now, the side that's opposite to the side that's the hypotenuse will always be that ratio. In other words, no matter how, okay, if I make this triangle smaller, 90 degrees, notice how this angle stays the same. If I make it even smaller, this angle is still 67.4 degrees. This side, the ratio of the opposite to the hypotenuse, no matter how small or big, will always be that same ratio, 0.92. Now, knowing that, even if I make the triangle bigger, look at 90 degrees. Bigger, 90 degrees. This side, opposite to the hypotenuse, will always be 0.9231. Now, how is that going to help us solve for the height of the building? Watch this. Watch this now. The angle we're dealing with now is 63 degrees. Remember my clinometer, my app? I got 63 degrees. If I type in now, watch this. Look at my calculator now. This x, this side x. So God, check it out. What is this side in relation to 63 degrees? Is it the opposite, the hypotenuse, or the adjacent? This side in relation to 63. Opposite on. It's not touching 63. So I'm dealing with the opposite side. What about, remember I was 6.75 feet away from the wall? What is this side in relation to 63? What is this side in relation to 63? It's touching it, so it's therefore what? The adjacent. So, out of the three ratios, seeking SOHCAHTOA. So, TOA. Which one of these three ratios has O and A? Tangent. Now watch this. Watch this. Here's a power now. On your calculator, the tangent of 63. Give me the ratio. Hit tangent of 63. Give me to the fourth decimal. 1.96 what? Does everybody get that? Salazar, we're good? Tangent of 63 degrees. No God? Tangent of 63. But you guys get that? All right, now watch this. The calculator's telling you something. The calculator's saying, look, this triangle here that we did outside, if I were to make the triangle smaller, watch this. The tangent of this angle, the opposite over adjacent, would be 1.9626. If it was even smaller, opposite to the ratio of this side to this side is 1.962. Smaller, smaller, doesn't matter how small or even how big it gets. Imagine me making it bigger and bigger, infinitely. The ratio of the side that's opposite to 63 degrees to the side that's adjacent to 63 degrees will always be 1.9626. So look what I'm going to do now. Knowing that, look what I'm going to do. Look at this equation I'm going to set up. 1.9626 equals, look at the ratio. What was opposite 63 degrees? What side was this? X on. Over the adjacent, 6.75. Look at this equation. The eternal ratio that will never change is going to be equal to x over 6.75. This is the height of the building outside. So let's get x by itself. Let's see. X is in the numerator right now. What can I do to both sides of this equation to get x alone? Let's get rid of the 6.75. So let's see. I'm dividing by 6.75. The opposite of dividing would be what? Opposite of dividing. Multiplying. So I'm going to multiply both sides by 6.75, which is the same thing as 6.75 over 1. I'll multiply this side by 6.7. Yeah, 6.75. Look what ends up happening. Bye-bye to that. X is alone. Just type that crap in your calculator. Okay. 6.75 times 1.9626. Round the nearest 10th. Can someone do that for me? 6.75 times 1.9626. Hit it. Tumbleweeds. Crickets. 13.24. One more? 13.24. Okay, so I'm going to go just to the nearest 10th, 13.2. Guess what we found, people? We found the height of the building. It's 13.2 feet. Because we know the ratio had to be that eternal ratio, 1.9626. The ratio of the opposite to 63 degrees over the adjacent had to be this, so we solve for x. X is 13.2 feet. So we're able to find the height of a structure without actually directly measuring it and climbing the wall. What kind of uses does this have in trigonometry? Well, we did a boring example here, right? The height of a building, so what? Who cares about the height of that building? But look at the things you can do with trigonometry. Since we know the tangent of 63 degrees will never change, what if you're looking for the height of a mountain? Here's a mountain. Look at it. All you got to do is figure out how far away you're from the mountain. Remember the way I figured out how far away from the building? Get a clinometer, your angle of elevation, and you can estimate the height of any structure. From what? Whatever way you want. You can still do the height, right? All you got to know is how far away you are from a building or from a structure, and then the angle, and you can find the height of any structure. How about stars up in the sky? You can use triangulation. How about an airplane? Anything. Just know how far you are from the structure, angle of elevation, and you're done. You got it. The uses of this are unbelievable. Yes.
Can you find the degree by, say we just give you the distance and the height?
Yes.
Can you find the degree?
You can find the degrees? Yes, that's called inverse trigonometry, which we're not going to be able to get into during the summer. But yeah, we could do that. All right, example 2. We found the height of the building. But I know just by looking at you guys, that was still kind of somewhat over your head, which is why I'm going to go over a few more examples. Let's go ahead and do example 2 here. here. Want to copy that one down? Instead of a question mark, though, go and put x. Put the variable. All right, how do we do this? Here we go. Is this a 45, 45, 90? Can't use that theorem. Is it 30, 60, 90? Nope, can't use that theorem. Can we use Pythagorean theorem? Why? Give me an argument. Why can't I use Pythagorean theorem? What if I want to use Pythagorean theorem? Who are you to tell me I can't use Pythagorean theorem? Right, there's only one side we know. So we're going to have to go to trigonometry. Here we go. The first thing you want to ask yourself is what ratio should you use? The sine, the cosine, or the tangent? What ratio should we use? Sine, cosine, or tangent? Well, that depends on what cards they dealt you. What is 5 in relation to 22? It's adjacent. It's touching 22. So I know that I'm either going to use the cosine, because look at adjacent's mentioned here, and the adjacent is mentioned there. It's either going to be between cosine or tangent. Well, let's find out. Let's keep going. What else do I need to find? What side is this in relation to 22? One more time, Ramos. It's opposite to 22, so I'm using tangent again. Notice how I picked it. Between the three ratios, the sine, the cosine, and the tangent, the one I picked was related to the sides that were given to me. Adjacent, opposite, I use the tangent. So now I'm going to write down my formula now, or my equation I should say. Here we go. So the tangent of an angle, in this case the tangent of 22, is equal to opposite of 22 is x over 5. Now, the tangent of 22, that's some number that your calculator knows in its mind. You don't have to type it in yet. But we know that this is just some number, right? Some ratio that never changes. So I'll leave it as tangent 22 till the end. But you need to have in your mind that this is just some number that the calculator knows. You don't know it. All you have to do is type it in there to know it. But this is just a number, a decimal number, a ratio number. We want to get x by itself. So what would I do to both sides of the equation to get x alone? Multiply, huh? Because I want to get rid of this 5. The opposite of dividing by 5 is multiplying by 5. So multiply by 5 over 1. Multiply this by 5 too. Whatever you do to one side, you got to do to the other. This is gone. X then is equal to 5 times the tangent of 22. Again, the tangent of 22 is some number that your calculator knows. You and I don't know it. This is why we can just press a button and the calculator will tell us. So what we're going to do now is we've got x by itself. Yay, we're done, sort of. Let's just type this in our calculator. 5 tangent of 22. It'll tell you how big x was. Let's round to the nearest tenth. I'm going to approximate. So 2.0. It's about 2.0. This side's 2.0. Right here. Would I be able to solve for one more time? No, you have to use a calculator. Yeah, because the tangent of 22, unless you have, way back before they used to have calculators, students would use a log book, and they'd have all these listed in like an index. You look for 22 and look for the ratio. But now the calculator does it for you. The tangent 22 ratio is some number, you just type it in. But before it was an index catalog.
So whoever wrote that,
all they were doing was all they were doing was this. Look at it. They'll create a triangle. Find 22 degrees. Look at it. Make sure that this was 22 degrees, and then find the tangent. Look at it. They'll measure this side and measure this side, and then round it to the nearest like fourth decimal, and then put it in the book. And then look at the next triangle will be what? Look at 23 degrees. 22. Let's make it bigger and bigger. See what the ratio is of each one. You see? Well, see all three angles have to add it to be 180, right? And this is going to stay 90 degrees. So the farthest you can go would be 1 degree here and 89 here, right? Because all three have to add up to be 180. So this is 1 degree, 89 degrees, 90. Be a weird looking right triangle, but that has a ratio too. So back over here, we solve for x using trigonometry. Last example before the break. Right here. Instead of a question mark again, let's put x here. Yeah. All right. So sine, cosine, or tangent. Let's see, SOHCAHTOA. Sine, cosine, or tangent. All right. I'm dealing with a 36-degree angle. This side is the opposite, so I know I'm gonna use this, the sine or the tangent. But this side, what is this side here in the triangle? Hypotenuse. So I know I'm going to use the sine this time, not the tangent. Okay? Notice how I picked the sine. It's because that's the sides that I'm dealing with. So the sine then of, watch this, 36 degrees, it's always of an angle. Remember, the sine of 36, that's some number. That's always stay the same no matter how big or small the right triangle is. That some eternal number that your calculator knows is equal to opposite at 7 over hypotenuse is x. Now let's get x right up and solve for x, we're done. Question is though, this one's a little bit different than the second example because the variable's on the denominator. So I have to get it out of the denominator because it doesn't help us when it's in the denominator. Veteran students, do you remember what to do here? What do you mean what? Okay. You turn the variable into a 1? No, because we're trying to solve for the variable. We want to know what the variable is. We can't just make it 1 willy-nilly. Well, what about the 7? So multiply both sides by 7? So I multiply both sides by 7, look what happens. On the right side I'll have, look at 49 over x. And this side I'll have 7 times the sine of 36. So I won't really have done. X is still in the denominator. So I have to get rid of it. So let's try again. Any other ideas? Veteran students, I'm counting on you to save the day. Salazar, Ramos. Divide by x? Okay, so that's the same as 1 over x. I'll multiply by x. Now we're talking. Claudia saved the day. Watch this. To get it out of the denominator, I'm going to multiply both sides by x, which is the same as x over 1. Multiply this side by x. Whatever you do to one side, you do to the other. Watch what happens. This is gone. So I have 7 on the right side, and I have x times the sine of 36 on the left side. X is not by itself now, but there's one more step to get it by itself. What do I have to do to both sides to get x alone?
Subtract.
By sine of 36? Close. You're close. Horton. Why should you choose division, Horton, instead of subtraction? Right, this is x times, so you do the opposite time. So I'm going to divide, watch this, by the sine of 36 on both sides. Look what happens. Gone. X is by itself. Yay! Just type this crap in your calculator. 7 divided by the sine of 36, and then round to the nearest 10. And we'll have to solve for x, the hypotenuse. 11.9?
Yeah.
Sounds good to me. We solve for the hypotenuse again. Trigonometry is powerful. We'll take a break in 10 minutes. After the break, we'll do a small table talk.